Okay, so we're just doing a review on the significant figures. So first is that there are some rules, and a review on that is that first, all non-zero numbers are going to be significant. Means that they are important, means they are counted. Okay, so if it is like 2.3 or 1329.26, each one of these numbers is going to be like you have to count them. So this becomes six significant figures in this case, two significant figures here. Let us say you have 2, 3, 9, 4, 6.32. Like this, some very big number. Okay, so there is no zero in between them, but 1, 2, 3, 4, 5, 6, 7. So these are all seven significant figures. These are all counted. Okay. Now let's look at the zero that is in between the non-digit numbers, like non-zero numbers. For example, the zero that is in between 3 and 4. So, but that is counted too. So that is why this becomes three significant figures. If you have a number that is the zero that is in between the two like digits, or in between the two digits, and there is a decimal point also, still in that case, this becomes a four significant figure. If you have a number like 1001, so in this case, all these numbers are important. All these digits are important. This is four significant figures. Okay, that's a simple one. Now comes the zero that is end of the decimal. Now here's a very important point. Now here I'm going to put here decimal, decimal. So decimals are, are important. Anytime you see a decimal, then that means zeros are counted. Zero, count those zeros anytime you see a decimal. So here is this number in which decimal is in the end, this zero. So that means the zero that is in front is counted. So that's why it becomes two significant figures. In this case, you look at this number, 152.000, three zeros after the decimal. All those three zeros are important. So they hold a place value. Okay, so in that case, it becomes six significant figures. So keep that in mind that anytime a decimal comes, the zeros are counted. The zeros are important. Okay. Next is a zero in the coefficient. If you write a number like a scientific notation, okay, a number that is written in the form of a scientific notation, in that case, yes, then the zero that is, in 10 is not counted. So this zero that is in 10, and then there is an exponent. So this zero, and then there is an exponent, positive or negative exponent, whatever it is. So this zero is not counted. Do not count the zero. So this is not a significant figure. This is not, that zero is not important, but the zero, if it is in this number like 5.70, that zero by default, anytime you have a decimal, that zero is always going to be counted. If you have a number like this, 5.07 into 10 to the power 3, and in that case there are going to be three significant figures because this zero is counted. Okay, all of them are important. Clear? Now let's go to the zero that is not significant. Zero that is not significant is the zero that is in before the numbers, because this number is 4 is counted, and the zeros that are in front of it, although there is a decimal here, but the zeros that are before a non-digit number or actual number is counted, is dropped. Those zeros are dropped. So that is why this is only one significant figure. These two zeros, again, this zero and this zero before this 7 and 5, 7 and 5 are counted. So when we say counted, that is what makes it two significant figures. Means those two numbers are important. So significant, if like in significant means important. So when we say significant, it means that like, should you include them in calculations, or should you include them in measurements or not? Okay, so that thing. Next is look at the numbers that are exact variables. Like for example, this is an exact number, this is an exact number, this is an exact number. There is no decimal here. Now, exact numbers, they have variable significant figures. Variable significant figures. Okay, exact numbers have variable significant figures. This means that because exact numbers can be written as scientific notations, you can write the exact numbers as scientific notations. Okay, this is the reason why there are they have variable significant figures. So for example, 10, 100 and 1000. So all of them will have one significant figure, which is this, which is fine. 100 can have two significant figures. 1000 can have two significant figures. 100 can have three significant figures. 1000 can have three significant figures, and 1000 can be four significant figures. Ideally, 1000 is four significant figures, but because they can be written in scientific notation, that is why we do not like we keep them as variable. Okay. So similarly, you look at this number 1250000, and yeah, 1 2 3 4 5 6 7. Yeah, there are 7 digits, so there are 7 significant figures. But these zeros can be, dropped, or you can write them in scientific notation. This whole thing can be written as scientific notation. So you can, if you write it in scientific notation, then it becomes 1.2. Okay, and then the decimal is right here. Let's write it in scientific notation. Okay, so here is your this number, 1250000. So here's the implied decimal. You don't see it, but it's there. 1 2 3 4 5 and 6. So you move the decimal 6 places. So this becomes 1.2 into 10 to the power 6. You see that? That same big number that was written in the standard notation, okay, in the standard notation, in scientific notation, it is written like, 1.2 10 to the power 6. So that is how there are only two significant figures, right? But it can also be written as three significant figures, depending, how exact you want your, calculations, or how sensitive you are to, number of places after the decimal. So it can also have three significant figures. So either way, it has a variable, right? Variable way, and it can even be more. You can put more zero. So in other words, those zeros that have a place value, yes, they give a certain, like understanding of a number. Like for example, if I give you $100 for a job versus $1,000 for a job, which job will you pick? Which job are you going to pick? Or which job are you going to accept? There is $100 for a job and there is $1,000 for a job. Which job are you going to accept?
1000.
The one that gives you, see, in your mind, see, that's the thing. In your mind, you are giving value to these zeros. Three zeros is more than two zeros. You see that? So that's why, those zeros have a value as regarding to the place value, but they can be, you can change and write them in scientific notation. So in that case, yeah, it's just less numbers. Anyways, now comes the rules regarding the numbers. Now, two rules. One is the rounding up and rounding down. So first thing is, in chemistry, because we are dealing with matter, we don't round down. Okay, but if we are writing, the rules regarding the rounding is, if the first digit to be dropped is 4 or less, then the digit that is retained, it remains as is. And this is with regards to if there is a decimal point. If there is a decimal point in the if there is a decimal point in the problem. Okay, question. Now another is, if the first digit to be dropped is 5 or more, then the retained digit is increased. Again, this is by the decimal point. Okay, again, if there is a decimal point in the question. Now for example, look at this digit. You have 35.7823 grams. Okay, and the question is asking you, write the answer. This is a question is asking you, your answer should only be up to three significant figures. Then what are you going to do? That means you need this number, you need this number, and you need this number. So these number you're going to keep, but you need to drop all the other numbers. And when you are dropping them, you see that 8 is more than 5. So therefore, what happens to 7? 7 gets increased by 1 unit. So that is why that the last number that was retained, that gets, by 1 unit. So this is your next 35.8, and you stop. On the other hand, if you have a small number which has all these zeros in front, and it is 0.0026217L, and here this is liters, here you want the answer up to three significant figures. So what do you do? So in this case, we want this number, we want to keep this number, and we want to keep this number. Why? Because these zeros are not significant. These zeros are not significant, are not significant figures. Okay, SF is significant figures. So 26217 we need to keep. Now out of that we only need 3. So we see that 1 is less than 5. So when 1 is less than 5, therefore 2 remains as is. So that is why your final answer now is, these will still be considered. You're not going to drop them. They will still be there. But we're just talking about, if we about this number is being dropped. So when you're dropping this, drop this number, and then drop that is less than 5. Therefore, the 2 remains as is. Okay, so this is as is. Okay, somewhere in the math, I've seen that they bring it down, like they round down. In chemistry, do not, in chemistry, do not round down. Because round down means cutting matter. Rounding down equates to cutting of matter. Mean you are reducing the matter, means you are throwing away the matter, and that doesn't make any sense to us. Chemistry deals with matter, so we cannot just take away and like you reduce the matter for, we can't do that. So in chemistry you run in a situation where you are forced to, or where the math calls you to round down. Do not round down, but keep as is. Keep those numbers as is. Okay, and especially those numbers are like here, I told you, as is. So keep 2 as is. Don't make it 1 or, less or something. Okay. Now look at this other number where you are given 3.8268. And here you need to have 3 significant figures. So in this case, 1, 2, and 3 you need to keep. But 6 is more than 5. So what do we do with the 2? We make 2 plus 1 becomes 3. And that 3 is here. So rounding up is okay. All right, guys. So this is about the rounding.